The include directive is essentially a copy-paste operation. In effect, it is what makes a file aware of another, or rather, that's the way you would normally think about it. Now, it doesn't exist in pure GLSL. I do not know the exact reason why, but I would suppose it is linked to how shader source is handled by the OpenGL API. As a reminder, the way that works is generally as follows. At runtime, you create a shader program. With that program, you create a shader. One then supplies that shader with both an array of C strings and the size of the array, i.e., the number of strings that make up the source code of the shader. As a last step, the shader must be compiled. One repeats these three operations for each shader in a program. Additionally, I've always found it rather convenient to also make some extra calls at shader program creation to find the location of vertex attributes, uniforms, samplers, buffer objects, and whatnot. To achieve greater efficiency, I had the idea of writing a structure that would describe a shader program to the very last detail, making it so initialization would merely require passing around a pointer to a constant. So what I came up with is a utility that fills out instances of this structure by passing GLSL source code and assembling that into a C++ header containing the details of a shader program. What follows is a rough description. First and foremost, I write the program in full. That means both vertex and fragment shaders exist within the same file. We separate the sources with these peso tags. For quality of life, the preprocessor will pick up any outputs declared in the vertex source and automatically convert them into inputs for the fragment shader, with the same name and type. We can also define author and version for the program, which is of no consequence at runtime, just cool to have. Now, running syngl on the file will make note of vertex attributes, uniforms, samplers, and buffer objects on both shaders and write that to a cache file. This cache contains an object with all of the data mined from the GLSL source. The preprocessor then outputs a C++ header that fills out the program structure and, as an added bonus, creates C-structs for each buffer object present in the shader. All of this just for ease of use. Initializing the program, then, requires only that this header be included and the address of the constant struct defined within that included header be passed to a constructor. The object returned by this method grants us with a full interface to the shader. With our shader program automatically translated into a C++ object, we can now have a second program that uses it. The mechanism is, you likely guessed it already, the include directive. What this does, basically, is append any definitions we wrote in the original shader to the new one. The preprocessor will look up the included program and fetch it from cache, if it exists, else parse it and regenerate the cache. The resulting C++ header will now contain links to the original definitions, plus anything else the second program builds on top of it. Not a full-on copy-paste operation, but close enough and still achieving the same effect. Programs can now be aware of another. Couldn't you do this by simply reading the files into an array of strings and passing that array to OpenGL? Yes, but it would be much more work. The purpose of this is giving you a ready-made system for creating shaders with ease. In a nutshell, syngl automates shader creation. You can use it to assemble programs that have been written block by block. It is currently at a highly experimental phase, but showing quite a bit of promise, and I will continue expanding it as needs continue to evolve. And yes, that's very much it. Simple and to the point. Include directives in GLSL source. Hoping you found this bit informative, I bid you farewell. Until the next episode. Ta-ta.